Well, a very warm welcome to this 4-week creation care course run in collaboration between HeartEdge, Melanesian Mission UK and Southampton University. You're all very welcome here, and it's lovely to see some of you who have come back for the session too, which is always a good sign. This series is part of Living God's Future Now, which is an online festival of theology, ideas and practice from the HeartEdge movement. HeartEdge is an international and ecumenical movement for renewal within the church, a network of churches growing compassionate responses to needs, cultural and commercial activities and congregational life. And we run a full range of workshops, and we work with churches individually as well. We're going to begin our session 2, which is focusing entirely on the science of climate change, with a short video for you.
We were sleeping and the police were going around with their microphone and announced to the village, "Get out, we're gonna hit by cyclone, out from your homes." But we still sleep. Say, there was no cyclone, no wave to hit here. We stay here for a long time. But after about half an hour, here comes the wave, roll, break through the village. You know, during nighttime, 12, 1 o'clock, midnight, all of us have to run for our life. With no clothes, no bedding with us, we just run up across the road and to the playing ground where the school is now, Woodford School. And all of us run and stay there for all night and all day, just sitting there and watch our house down. All our buildings down, covered with logs, covered with sea stones. And we just sit down and wait until the weather go down for 3 days. Then we just come and clean up and come back again. From the first time, from the main road to the sea is more than 120 meters. It's now 55 meters. Half of the village is now left. The water now, or the sea now, is pushing us up. And you see the main road, we can't move up now. We have to stop here now. We are now building the house high, but the latest one was coming with the logs, and the wave bring them here, back to the village, and rocks getting worse these days. The height of the sea is now rising every day. Our old man always say, okay, Koburu, westerly wind, Hara, easterly wind. So by the moon. But now all those are changes. I think the best thing is we have to move out from this place here. So I'm afraid. Climate change is really a climate change. If I have enough money, I can buy the land from the Watercan people and build a house. But if I have no money, then I think the best thing, I just stay here and wait to face the weather.
Oh, it's a real privilege this afternoon to have with us Marie Schlenker, who really is immersed on a day-by-day basis in the science of climate change. And she's going to be speaking in quite some depth for an hour and a half with us today about the science of climate change. And Marie is a PhD candidate at the University of Southampton, researching climate change impacts in Solomon Islands particularly, and we've just been seeing that video of the Solomon Islands. Marie conducts her research in close collaboration with the Anglican Church of Melanesia and the Melanesian Mission UK. She holds a BSc in Geosciences, an MSc in Environmental Physics, and a postgraduate certificate in Disaster Management. And so over to you, Marie. It's really wonderful that you've given up your afternoon to educate us, and we look forward to what you have to say.
Thank you, Cass, and a very warm welcome to all of you today. So yeah, you've just already heard a lot about me. So I'm studying climate change impacts in Solomon Islands, such as in the fishing village that you've just seen there. So I'm really focusing on erosion and rising sea levels and what that means to people, and especially whether they have to relocate. Yeah, there will be quite a bit of science going on today. Yeah, I'm trying to make it as simple as possible, but also feel free to ask questions throughout the talk in the chat, and we will come back to them at the end. But if you have a question at some point, just put it in the chat so that it can be answered at some point. And don't worry, you know, no question is a question that shouldn't be asked. No question is boring or insignificant, so just go for it. And I know that this might be a bit science heavy, so yeah, really don't worry to really ask those questions when needed. And I will come back to my presentation now and actually start talking about climate change. By the end of the session, you will hopefully be able to define what climate change is, explain the drivers and processes underlying climate change, know about the existing evidence of climate change, and understand how scientists provide estimates of future climate change. So how do these estimates actually come from? How do we get them? And know about the potential risk and impacts of climate change, as well as identify some risks and impacts for your local environment, so the local area that you're living in. So for the Solomon Islands, as you can see on the left-hand side, that will be, for example, sea level rise as the biggest risk, but that might be completely different depending on where you are living in your local area. And that will be the part that will be interactive again when you get to talk in breakout rooms. Everything before will be a bit more me talking and just informing you about climate change. But yeah, I would like to get an idea of what you already know about climate change and what you would like to learn. So if you could just kind of give me your idea of what climate change is into the chat again, that would be really helpful for me to get a better idea of what level I will need to base my scientific talk on. So if you already kind of have an idea of what climate change might be, just feel free to put that in the chat, whether that's sea level rise, as I've just mentioned, or something completely different. Your first thought that comes into your mind when you think about climate change. What is climate change? And it would be amazing if you could share that in the chat with us. And yeah, if you have one specific question already in your mind about climate change, then you could also put that in there right now as well, because that will make it easier for me to come back to it later on. So we already got unpredictable weather patterns. Thank you, Cass. So I'm going to put sea level rise in there, although that's only part of it. Global warming and loss of habitat. Increased frequency of natural disasters. Yeah, these are all really good ones. Rise of sea levels, increase of desert levels, decrease of ice areas. Yeah. Changes to ecology. Changes of weather patterns, advance in melting ice in the Arctic. Yeah, just keep these coming in. We'll get back to the screen share now, but we will talk about all of these things that you've just mentioned. They're really good. That's really good input already. So what is climate change? So to understand climate change, we need to understand what is the difference between weather and climate. So weather generally is what we get each day. So these are the conditions of the atmosphere over a short period of time. So you look out of the window and that's the weather that you see. So whether it's rainy, and that can change within minutes or hours. So it's really short term, versus climate being what we expect to get. So what weather do we expect to get in a specific month? For example, the average temperature in May or in June. So how the atmosphere behaves on a very long time period, and also over bigger geographical areas. So it's the average regional weather pattern over decades. And when we are looking at climate change, we're usually referring to changes in the state of the climate on over 30 years of time. So, you know, to say the summer was a lot warmer last year, that's not necessarily directly climate change, because you always need to see it in the big context, 30 years of time or more. And generally, when we speak about climate change, we're also referring to the human-made, so-called anthropogenic climate change due to our human activities, industrial activities and land use changes. And we'll come a little bit more, learn more about that later on. And then this climate change comes from global warming. So global warming is the increase in global mean surface temperature. So the average temperature across the entire globe near the surface over a 30-year time period. And that's what scientists refer to when they talk about global warming. So global warming is always global, as the name says, and climate change is also global. It's not a regional phenomenon. It is happening on the entire planet, and it is happening on very long time periods. And because of this warming, we get changes in the climate system that then lead to these things like the changes in the weather patterns, more extreme events, and so on. So how does global warming actually work? And to understand that, we need to understand the so-called greenhouse effect. So by looking at this image, and I will talk you through this, don't worry. So we have the sun on the left-hand side, the number 1. So radiation from the sun travels towards the Earth and hits the Earth's surface. And at that point, half of the radiation is actually absorbed by the Earth, generating heat. So it's absorbed by the oceans particularly, but also by the land. And the other half gets reflected back towards space. And part of that is actually absorbed by the clouds and the atmosphere, and the other one just kind of continues through back into space. But what is really interesting is what happens to this kind of radiation that has hit the Earth, because the Earth is actually changing this radiation from very short wave radiation to long wave radiation. And so long wave radiation basically means heat. So it's also releasing heat back. And that heat, because of the change from short wave to long wave radiation, then gets trapped by different gases in our atmosphere. And these gases also reflect parts of the radiation back to Earth. So this is what you see on the right-hand side here, all these ups and downs. And this is really how the greenhouse effect works. It's kind of keeping this heat trapped in our atmosphere. So if you want to think about greenhouse effect in a very simple way, without thinking too much about all the radiation that is happening here, it's basically trapping heat in the atmosphere. And it's a natural effect. So it's actually necessary for our survival on the Earth. Without the greenhouse effect, we would have a temperature of minus 18 degrees Celsius here on Earth, rather than an average temperature of presently 15 degrees Celsius. So this is a thing that has always been happening. However, as humans, we have artificially enhanced this effect in recent years by releasing more gases into the atmosphere that can trap heat. So basically, more greenhouse gases in our atmosphere mean that we will have a stronger greenhouse effect on top of the natural one that lead to warmer global temperatures. So if you're taking one thing away, then that is that the greenhouse effect is trapping heat, and more greenhouse gases mean a stronger greenhouse effect and a warmer global temperature. So what are greenhouse gases? So these are the gases in the Earth's atmosphere that trap heat. And there are some primary greenhouse gases, and these are actually the most important greenhouse gas on Earth is actually water vapor and not CO2. Water vapor is our most important greenhouse gas. However, it's a natural one. Then we have carbon dioxide, methane, nitrous oxide, and ozone. And in the last a couple of centuries, since the start of the Industrial Revolution around 750, we have increased the amount of greenhouse gases in our Earth atmosphere. And that's what you can see on the graph of the right-hand side. So we can see how over time we have increased concentrations of carbon dioxide, methane, and nitrous oxide. And these are really the three that we are influencing mainly with our human activities right now. And what you can also see is that we started to increase them slightly and then started to increase them more and more. So it's an actual exponential increase in greenhouse gases, a very strong increase in recent years. So this atmospheric concentration is just kind of a balance between any sources of gases that are emitted and any sinks, how they might be removed. So as you all know, for example, carbon dioxide gets removed by plants through photosynthesis and transferred into oxygen. But because we're putting so much more CO2 in the earth, that's how we're tripping this balance a bit, and that's how we get the larger concentrations. So where do these come from, these gases? So for carbon dioxide, if you look at the table at the top right corner, the main sources are actually fossil fuel combustion, cement production, and land use changes, for example, by deforestation in the Amazon forest, mainly rainforest really. And then methane, again, fossil fuels, rice paddies, waste dumps, and also livestock is a big one here. And for nitrous oxide, we got fertilizers, combustion and industrial processes. So it's not just burning CO2, it's actually a lot of different things as well. And that's also what the graph on the left-hand side shows. It kind of shows us which contributions come from different sources. So for 25% is generation of electricity and heat. 20.4% is actually agriculture and land use changes. 17.9% are coming from industry, 14% from transportation. Then there's a bit of other energy, 6.7%, so quite a bit, is just coming from food waste. And then the other 6.4% are from heating buildings. So you can see there are different ways how we are influencing our greenhouse gas emissions in our daily lives. And we're currently increasing them. So in March 2020, we were at a concentration of 413.76 parts per million. And that's in comparison to 280 pre-industrial. So we are on the way to really nearly doubling our greenhouse gases. So now I would like you to take a minute and just kind of think about how some of your daily activities contribute to the greenhouse effect. So if you just come up with 3 examples of things that you do every day that enhance the greenhouse effect, where we are releasing greenhouse gases. So if you could use a chat for that, that would be really helpful. Yeah, as Kath has said, please put your reactions in the chat. You're surprised that it's only 40% transport. Yeah, I was surprised by the food waste in that one, and also by the agriculture one. So those are really big ones, actually. So Ruth has said driving, heating, and eating. I think, yeah, all 3 of those are definitely things that we do each day. Driving, fuel in the home, food waste, eating meat, food waste, central heating, driving a diesel car, leaving lights on, charging cables left on, heating water. So lots of things that we do in our everyday lives. And I think it's just really good to look at this graphic and just kind of take a step back and reflect on things that we do each day that kind of contribute to this greenhouse gas effect. I'm gonna start sharing my presentation again, but please keep these suggestions coming and these ideas. So the next thing is, where are these greenhouse gases emitted? So who is emitting greenhouse gases? And on the one hand side, on the left hand side, we can see the annual absolute CO2 emissions. So these are the actual tons of emissions that we are generating in greenhouse gases. And you can see the biggest emitters there are China by far, the United States, and India, followed by Russia, Japan, Germany. However, this picture becomes quite different if you're actually looking at the per capita emission, because China is it's by far the biggest carbon dioxide emitter, but it's also the most populous country in the world. So more people obviously mean more emissions. But if you're looking at the per capita one on the right-hand side, that's really when the US, Australia, and also a lot of our European countries have to also think more about it, because we are actually the biggest emitter when it comes to carbon emissions per person. So it's just good to keep this in mind. And that's these two graphs kind of show why these negotiations on climate policy are so difficult. Because on the one hand side, you got the absolute emissions versus the relative emissions. And it's always hard to cut down on greenhouse gas emissions if you just thought about, you're using greenhouse gases, you're contributing every day. So countries are often very hesitant when it comes to cutting them down and making actual commitments. And this kind of shows that it's difficult to, decide who might have to cut down more than other people. And it's just kind of explaining a lot of the politics behind these greenhouse gases as well, if you're interested in that. So now we're coming to the evidence of climate change, and all of that I will be presenting for most of my talk today will actually be based on the IPCC, the Intergovernmental Panel on Climate Change. So this is a group of scientists that comes together to really give the current state of research on climate change by the international scientific community. So it's an intergovernmental body of the United Nations dedicated to providing the world with objective scientific information relevant to understanding the scientific basis of the risk of human-induced climate change, its natural, political, and economic impacts and risks, and possible response options. And they create assessment reports every couple of years. And I would, if you're really interested in this, I would recommend you to actually open the summary for policymakers in one of these reports and actually read through it, because that's kind of where you will find the best state of research and evidence on climate change that is currently around in the scientific community. I will talk you through some of these today, selected ones that I thought were really interesting. And I think the main finding of these reports really is that there is evidence of global warming, and it's unequivocal. Global mean surface temperature has risen by 1 degree over the period from 1950 to 1980 to now. So it's always on this 30-year period. That's why you don't get like 1 year, but you get a 30-year period, and that's compared to our present 30-year period. And it is the increase in temperature is accelerating, and that's what the graph at the bottom really shows. So you see that the increase speeds up over time. And the warmest years on record so far have been 2016 and 2020. I don't know why my PowerPoint is always moving here. I'm very sorry about that. And the rates of temperature increase are unprecedented for the last millennia. So this is really something that we are causing as humans in recent years. And when you look at these warming stripes on the right-hand side, so these are kind of in comparison to the average temperature over the time period from 1971 to 2000. And someone has just color-coded this to show kind of whether years are warmer than the average or colder than the average. And you can see that really most of the years that are warmer than this average have been throughout the last couple of years that we've seen. So it's really something that has picked up in recent times. And it's not just the air temperature that is changing, it's also the ocean temperatures that are changing. They're increasing, especially near the surface. So with ocean heat uptake, it works that way that there's an exchange between the air and the ocean. So first you will have the surface warming before you will have the lower ocean warming, because the heat needs to be transferred through the ocean down to the deep ocean. That's a process that is happening on very long time scales of over hundreds of years. So most of the heat that we're currently actually taking up on the Earth is actually stored in the ocean. And right now it's still in the surface ocean, but it's slowly being transferred down into the lower ocean. And this is really important to keep that in mind, because these are changes on long time periods that are not really easily changed again. So once the ocean has taken up this heat, it will be stored in there and it will be there. And that's especially interesting when it comes to sea level rise. And I will talk a little bit more about that later. More evidence of climate change is the extent and thickness of the Arctic sea ice, which has decreased over the last decades. And that's kind of what you can see here in the graph. It's the top line that you can see, and you can see the decrease over the period from like 1960 to recent years. While in the Antarctic, that's not seen that much yet, but we're talking about just sea ice here right now. So sea ice is the ice that is floating on the top of the ocean, versus in the Antarctic, you have a lot of ice masses that are actually, Antarctica as a continent, so it's actually on land masses. So that's a different type of ice. But as you can see here, these big ice sheets that are on top of actual land have also decreased in mass significantly. So Greenland lost around 281 billion tons of ice per year between 2002 and 2016, while Antarctica lost around 125 billion tons of ice. So these red areas indicate where the biggest loss is happening, and the graphs obviously as well show the ice loss. And this is really what is worrying scientists the most, the loss in the ice sheets, because that leads to sea level rise, especially. More evidence, glaciers are retreating around the world. So if you look at those pictures from Pizzol Glacier in Switzerland in 2006 and 2018, I think that's an image that really shows that the ice is just gone. So that's taken in the same months in different years. And it's tiny now, basically. The spring snow cover in the Northern Hemisphere has decreased over the past 5 decades, and the snow is melting earlier as well. Permafrost temperatures in the Northern Hemisphere have increased, and that's another one that is worrying scientists a lot, because this permafrost might also lead to significant changes, like so-called tipping points that scientists are always talking about. So these tipping points are kind of points of no return. And once they've been hit, it is really hard to reverse the state of the climate back to what it was before. And that's really in the permafrost and in the big glaciers, right? The big ice sheets in Antarctica and Greenland right now. And that's kind of, there's a big uncertainty around this right now. So these are changes that have already been happening. But we will also talk about projections in the future a bit. And that's where these tipping points are really coming in. We've already seen some sea level rise. It's only been around 23 centimeters since 1870 thus far, so it's not that much yet. However, it's definitely a clear trend, and there's no way that you can deny that sea level rise is actually happening. So the causes of the sea level rise are actually twofold. So we get water added from these melting ice sheets and sea ice and glaciers. And then we also get expansion of seawater as it warms. So that's actually nearly, it's a really big effect as well. So when water molecules in the water get warmer, they need more space. And that's how it then expands. And at present, we have a rate of around 3.3 millimeters per year of sea level rise. So it sounds really, really small, but if that adds up over centuries, you get quite high rises actually, and it's also not globally the same everywhere. So you always see the global averages here, but regionally, climate change might be very different depending on where you are. One of the biggest, actually obvious signs of climate change already is ocean acidification. So that means that the pH of the ocean surface decreases, and that leads in an increase in acidity. And so far that's been around 26%. And this is really worrying because that affects corals in tropical waters quite significantly. So corals are really sensitive to changes in their environment, and they don't like acidity. So that basically means that there's a lot of coral bleaching going on. You've probably seen all these like images of like white corals in the news at some point. So this is where that comes from. It comes from the increase in the acidity and also the warmer temperatures in the water. And yeah, another one that will likely happen is that the zones where you don't have much oxygen will increase in recent decades. as well. This one is not really conclusive yet, but there is some evidence of more extreme weather events. So overall, the number of warm days and nights have increased globally. And we've also seen heat waves in Europe, Asia, and Australia on an increasing trend since 1950. However, what is not so conclusive yet, which is always suggested, changes in droughts, heavy precipitation, flooding, tropical cyclone patterns. There are some projections happening, but so far, they could not be attributed with high confidence to climate change. Scientists kind of agree that this will happen in the future, but so far the evidence is not conclusive that these effects like the tropical cyclones and the flooding are definitely a cause of climate change, and I would say yet. There's a lot of research going on right now, and I think the new IPCC report will already shed some more light on this. But so far the main evidence of extreme weather events are really the heat waves and the number of warm days. So just for you to kind of recap this section, because there was so much going on right now, is if you could think about 3 examples of evidence of climate change that you still remember and put those in the chat, that would be really, really helpful right now, just for you to get some minutes to rethink about what I've just been presenting. Yeah, so for the flash flooding, that one is something that is not necessarily been proven to be connected right now. It might be a climate change effect, but it has not been proven right now. But the coral bleaching definitely has been proven already. Sea level rise, yes. More warm days. Ocean acidification, ice sheets, yeah, sea level rise, great. So yeah, the typhoon in Australia, same situation there. There is a lot of projections going on, but so far the evidence is not conclusive yet to be just caused by climate change. Okay, I'm going to jump back into this presentation. So what are projections? Projection is a prediction or an estimate of something in the future based on present data or trends. So this is what scientists often use when they talk about, cyclones are getting worse and so on. This is usually the projections, their models, their climate models that they have been based on. So this is what I'm going to talk about. How are these projections actually happening? How do we know what will happen 50 years in the future? So projections of future climate are generally made by climate models, which use a described scenario of a greenhouse gas or an air pollutant emissions and various land use changes as kind of an input into the model. And these emission scenarios are highly dependent on the economic and population growth that is assumed in this model, as well as changes in personal lifestyles, technology, and climate policy. So what I'm saying here is there are a lot of things that feed into this model, just when it comes to these greenhouse gas scenarios that produce some uncertainty about what will happen in the future, because we have to make assumptions about, is the population going to grow as it is right now, or is it going to grow more faster? Same with the economy. So there's a lot of, I would say, good guesses that scientists have to take here. And this is where some of the uncertainty for these models are generated. That's why I can't say in 100 years from now, our sea level rise will be 100 meters. That's impossible to say for a scientist, because we have to work with these variables of, what might happen. And we are always taking best guesses as scientists, the one that we can get from our research, but it's still a projection into the future, and no one has lived in the future yet. So there must be some uncertainty represented with this. And in the IPCC, to kind of account for this uncertainty that is there, we are using something called representative concentration pathways, short RCPs. And these are 4 different scenarios usually that are used: RCP 2.6, RCP 4.5, RCP 6.0, and RCP 8.5, which kind of represent different pathways of potential climate greenhouse gas emissions in the future. So they're all based on different economic and population models. And currently, we are really headed towards these high-end RCPs 6.0 and 8.5. So if we're not doing anything, we will head towards those high emission scenarios that these models are using. They also run these scenarios with other models to see what would happen, for example, if we suddenly cut down all our emissions. But if we are going on like as business as usual, we will end up with these high emission scenarios. That's kind of what we are headed to right now. So under these higher emission scenarios, changes in air temperature are highly dependent, as I said, on these emission scenarios, but they could be anywhere between 0.3 degrees and 4.8. But because we are heading towards these higher emission scenarios, a number closer to those higher degrees is more likely at this point in time than the 0.3 degrees. And that's kind of the difficult part to understand with these projections. It comes from the try of scientists to account for the uncertainty. So it can be anywhere between 0.3 and 4.8. This is kind of the this like corridor that scientists have identified, which might be a scenario. However, under our current, way of living, we are way more likely to head towards a scenario that looks more to the one on the right-hand side, RCP 8.5, than the 2.6 scenario, unfortunately. But it also shows that we, as humans, still have a big part to play and have an option to actually, end up on the more lower side of things. And what this also shows is that there are huge regional differences in what will happen with the air temperature. And you see that the biggest warming will actually happen in the Arctic Ocean. So it's really likely that the Arctic Ocean will become ice-free at some point in the near future because of the warming there. Precipitation is generally really hard to model with climate models. So depending on which climate model you're looking at, you might see very different results. And precipitation changes are generally also not uniform globally. So you won't get more precipitation in general on the Earth. It will change from parts. What we're generally seeing, what these climate models kind of agree upon, is that high latitudes and tropics will receive more precipitation, and mid-latitude and subtropics will see decreases in precipitation. So basically, tropics, areas that are already wet will get wetter, and dry areas in the subtropics will probably become even more dry. That doesn't mean that a specific area, for example, in the UK, will necessarily fall into this pattern and will become less wet, for example. But it kind of gives a general overview globally what will likely happen in the future. Ocean temperatures will continue to increase throughout the 21st century. Changes in sea extent are highly dependent on the emission scenarios, as you can see here on the right-hand side. So for example, under the 2.6 scenario, which is we would have to drastically change our emissions right now, you see there is a decrease right now, but it could be stabilized and we could actually keep some of our Northern Hemisphere sea ice extend in September. But if we're looking at our RCP 6 and 8.5 especially, we see that we might lose the entire sea ice cover in the Arctic beyond 2050, so around 2070 probably. So yeah, again, what this shows is we have a high influence on what will happen in the next couple of years. There are also going to be decreases in snow cover, glaciers, and permafrost. I don't have the graphs for that right now in here because I'm trying to give an overview of what will happen. Another really interesting one is the sea level. And the most important thing here to remember is sea level rise will continue through centuries with what we've already done now. So in most of these pictures that you see, or most of the predictions that the IPC does, they all end in 2100, because that's kind of the period that has been agreed upon by the UN to look at. So you know what will happen throughout the century. However, with sea level rise, it is very interesting to look further than 2100 because of this deep ocean heat uptake that I've mentioned earlier. Heat is slowly transferred and is happening right now, and there's no way we will get out of it anymore. So if you're looking at the top graph in the top right-hand corner, Under a high CO2 scenario, we will have a meter of sea level rise by the end of the century. That's kind of the number that people always mention. It's actually more likely to be around 80 centimeters. That's what the IPCC says right now. However, if you look further, if you're looking throughout the centuries, and this is something we are committed to, this is not something we are going to change anymore. These numbers are going to rise. Even under a low CO2 emission scenario, we will have over a meter of sea level rise by 2500. If we have a high emission scenario, we are at 6 meters of sea level rise in 2500. So it's important to keep in mind that changes in sea level rise just don't stop anymore. Even if we cut all our emissions right now, we are committed because of the ocean heat uptake. And there are huge discrepancies whether we have a low CO2 scenario or a high CO2 scenario. So making the right choices now will affect generations of generations later on this earth. And I think that's really the main takeaway from the sea level graph here. Sea level rise is likely to accelerate over time. So far we've only seen 23 centimeters, but globally. But it will increase faster in the future, according to these projections that are made on the best assumptions that scientists have. And more importantly, they will not be uniform across the globe again. So on the right-hand side in the graph, you can see that there will be regional differences in sea level rise, with a lot of it being in the Southern Ocean, actually. And when thinking about sea level, there is, the anthropogenic human-made sea level rise that I'm talking about right now, but then there are other things on top, like storms coming in, regional variations in sea level due to other climate phenomena, such as the El Niño Southern Oscillation, and they might all add up on top of the sea level rise, and that's what's leading towards more extreme events, and, for example, the flooding in Solomon Islands as well. Ocean acidification is also supposed to increase, unfortunately. So anywhere between 15 to 109%, depending on the emission scenario. And I think what I really want to show here is just the big discrepancies between our RCP 2.6 scenario, which is if we really drastically make changes now, versus our 8.5 laissez-faire scenario, in which we just continue living like we do now, and how much that actually affects these numbers. So in Solomon Islands, that's a small island developing state with over 900 islands. There's a population of around 650,000. It's tropical, and there are many small villages still around that just kind of live off subsistence agriculture and fishing. So that's kind of setting the scene for this country. It's a really poor country as well, in terms of the economic value that is generated in there. The temperature has so far increased at around 0.15 degree per decade in the capital Honiara. So there's only a slight increase in temperature, but it's definitely there. And rainfall has varied a lot from year to year, making it very difficult to identify any trends in it. And rainfall patterns have also considerably varied between different islands in the country. And at the present, there's the problem that there's very scarce data out there. There are not many weather stations in Solomon Islands, or generally in the Pacific, actually, the entire area, which makes it difficult to see what is happening in a country that is most likely at the forefront of climate change. So if you're thinking about these island states and sea level rise, these are really countries where you will see some of the first changes, again, to the corals as well. But these countries often also lack the finance to actually have these monitoring systems in place. So what we rely on a lot in Solomon Islands is satellite data. So overall, we've only seen a sea level rise of 10 centimeters since 1950 so far. However, it's projected to be around 1 meter at the end of the century. And recent satellite altimetry data shows rates of around 8 millimeters per year around Solomon Islands, which is significantly higher than the global trend of 3 millimeters per year. And that's kind of where all these things that I mentioned before come in. These higher rates are due to changes in the El Niño Southern Oscillation, which is a climate phenomenon in the Pacific that kind of affects the weather patterns and also the sea levels on like timescales of around 7 years. And that affects kind of how the country is already seeing the flooding and things like that we've seen in the video right now. So in a way, the Solomon Islands are really kind of a test site, if you want to say it like that, of what might happen in a lot more countries and coastlines along the world in the future, because we're having these higher rates that are projected by climate change scientists to happen across the entire globe in a couple of decades. We're already seeing these higher rates right now in Solomon Islands. It's not all due to climate change, but it can be regarded as a site to see what the future will bring us, basically. And that's why scientists like myself, I'm working in Solomon Islands. I'm looking at community relocations due to increased flooding. This kind of shows us what will happen in a lot more places around the world in the future. So looking at potential impacts of climate change, we got the greenhouse gases and land use changes in the middle as kind of the drivers of all this. And then we see the changes that are happening in the climate system. And these are the things that I just talked about. So warmer land and air temperature, warming oceans, melting ice, rising sea levels, ocean acidification. Then there's also something called global greening. So due to higher temperatures, we actually get more vegetation. Then changes in ocean currents, more extreme weather, changes in the hydrological cycle and precipitation. So this is all the stuff that is happening due to the greenhouse gas emissions. And on the outside, we have what that actually means for people potentially in the future, but also in sites like Solomon Islands, where some other climate things are going on right now already. So that's more flooding, both from rivers, but also from coast. And we have damages to marine ecosystems. As I mentioned before, the coral bleaching is really one of the most visual signs of climate change on the planet right now. It's showing it's actually happening. That might mean that fisheries are failing in countries like Solomon Islands, for example, where people really depend on fishing. That would be devastating. There's loss of biodiversity, changes in seasons and growing seasons particularly. That means harvest might not happen at the same time anymore. Heat stress, that's something that we've been actually experiencing here in Europe. There have been a lot more deaths in recent years, especially in 2016, due to prolonged heat waves. The region that pests such as mosquitoes can live in will expand. That means diseases like malaria might be expanding to more areas. There's forest mortality and an increased risk of wildfires, damages to infrastructure, for example, from the flooding or from storm events, and the risk of food insecurity and risk to water supplies. And that might ultimately all lead to conflict and more migrants, as we see is already the case in Solomon Islands right now. So I think the point that I really want to make at this point, after we've discussed all these potential impacts and it's kind of painting a really bleak future, I think it is worth remembering these different emission scenarios and how these curves are very different, whether we are looking at a 2.6 RCP or an 8.5 RCP. It shows there's a lot of things, a lot of variability that we as humans can actually still influence. But now it's the part to get a little bit more interactive here. We still have about half an hour actually to really delve down into some of the climate change impacts and also your questions. But yeah, talking about small island states, I kind of wrote down all these different changes to the environment. Which ones do you think might be the biggest threat in a small island state and why? So if you just kind of want to put that in the chat, I think that would be really useful. Yeah, as Kath has said, it's an incredible circle of impact. Yeah, I think changes in sea levels are definitely a big one. In small island states, I think you picked one of the most important ones right there. I think the melting ice and the changes in the ocean currents are kind of indirectly having an impact on there. So the melting ice, obviously, through the sea level rise. Same with the ocean currents. That might also impact fisheries, actually. Yeah, for everyone who lives on the coast, sea levels, extreme weather events, I think, yeah, that's another really big one. Increases in tropical cyclones might be one. Scientists are really still not sure about what will actually happen with these extreme events. That's why it's not included in the presentation right now. There is some evidence that the number of tropical cyclones might decrease, but the intensity will increase. So that means we get less tropical cyclones in Solomon Islands, but more extreme ones. But because this evidence is not, so all I've presented today has really the up of, I would say, 99% of the scientific community. And that's why it's in this IPCC report. Everything that is not that clear yet is not mentioned in the IPCC report. So there will be studies that will come up with these ideas about tropical cyclones, for example, and probably they're right. But to be included into this IPCC report, a lot of scientists will have to have the same results for it to be included. So what I've been presenting is really the state of what we know right now. And there are a lot of other things out there already, such as, the tropical cyclones and their intensity, but they haven't been verified to that same degree yet. That doesn't mean that it won't happen. But yeah, all of what we've seen today is definitely, yeah, very, it's like it's state of the art, basically. Food production levels and access to drinking water. I think that's a very important one for those smaller island states as well, especially if we think about, the village that we've seen in the beginning that is still like living off subsistence, agriculture and fishing. Loss of sustainable living. Yeah, I think these are all really good suggestions. So now we have some time, actually. We've been thinking a lot about Solomon Islands now, because that's kind of what the focus of this workshop is on. But I would like us to kind of think about our own environment right now, whether you are in the UK or anywhere else in the world. And we will go into small breakout rooms and have a 10 to 15 minute session, actually, to kind of think about what are things that might be happening in your environment in the future. If you think about all these changes, what could be potentially a problem in the UK? It's always good for us. We always think climate change is far away from us most of the time because we're quite detached from our environment. But if we actually think about, the higher sea levels, rising temperatures, what does that actually mean here in the UK, for example, or in your local area? I think that would be one good question to take into these breakout rooms. And the other one would be just to reflect on what I've just talked about. If there are things that really stood out to you that you didn't expect as well, or questions as well that you still have in your mind and really want answered in a question and answer session afterwards, that would be really useful as well. So I think Cass will go ahead and put us all into rooms of 5. Welcome back, everyone. Sorry, I was on mute and I didn't realize. I hope you had some good discussions in your breakout rooms. I think we certainly had a really good one in the one that I went into. And I think it's worth really diverting a bit from the plan that I initially had and just kind of coming here and kind of sharing a bit of the main takeaways that you had from the session for yourself, for your church, and also questions that you still have and that you would like to ask me. So I don't know if, Kath, if you've already seen some questions in the chat. I was kind of busy looking at the presentation, but I'm happy to take any questions that you have. And I think it is also great if you already have if you have certain things in your mind that you would like to share with the group here to discuss, I think this would be a really good forum for it right now. Yeah, so.
Great, Marie, we definitely have some questions already in the chat. I wonder if I've got them listed here. If people would prefer not to ask them, just say so. But I know Barbara Harrison had a question. I wonder if she might ask it about the percentage of the electricity from homes and industry. What was your question there, Barbara?
Yeah, was it 20% you said was from electricity and heat from homes and industry in quite an early slide? I just wondered what percentage was, if you knew what percentage came from homes and what from electricity. It was just that I was on a meeting last night, and somebody said that that homes were the most contributed most to climate change. What with the food we waste and our use of electricity and our cars and all the other things.
So the 25, so there's a 25%.
25, I couldn't remember the
in here.
percentage.
However, that is just kind of the fossil fuels that are released to generate the electricity and heat then, and that's used in both industry and homes. So unfortunately, this figure doesn't necessarily like split it completely into what is used by private people versus industry. However, I think what we need to remember here is that in a way, we are consuming all of this, even if the electricity is used by the industry. You are using then the plastic chair that they've manufactured, for example. So in a way, it always comes back to us as people of what we're using here. I think the direct ones that are going back to people here are the food waste and the buildings. But then if you look at the agriculture, you know, if we decide our food choices also then kind of impact, you know, the quantities here. So I think it all comes down basically to our individual choices at the end, really, regardless of what the percentages here are. Yeah.
Thanks very much.
That's great. How about Katrina? I know you asked a question. Would you be willing to come and ask your question about competing?
I was just wondering, with the amount of impact global warming has on the fact that we use a lot of computers now, so the amount of electricity that we're using now compared to, say, in the 50s, 60s, 70s, there'll be a large increase of electricity being used with the use of the internet and computers now.
Yeah, I mean, obviously all electric appliances take electricity here. I think that we are also saving some actually like greenhouse gas emissions by using our computers. So if you think about this right now, we are all sitting in front of our computers, but we are, you know, like we are still communicating with each other versus imagine if we would have all traveled to, let's say, a place in London, flown in from a different country, and then had our meeting. So I think it's hard to say it's all due to the computers, for example. I think computers are part of our modern life, and they've also brought us a lot of advantages. It is impossible for us, I think, to, at this point of time with the technology that we currently have, I think there will be some, you know, somewhere we need electricity. Like, I don't think that we will have a society again that will not use electricity. The question is, how is this electricity generated? Are we using sustainable, you know, electricity, or are we using what we, you know, like, are we using fossil fuels? And then also, is our computer energy efficient or is it not? Yeah, I think, you know, there needs to be a balance in the choices that we make, whether I don't think that we can just say we are shutting off everything and we're returning back to our society a couple of 100 years ago. But yeah, every new gadget, the fact that everyone has like 1 or 2 phones now, this is all resources, this is all electricity. Yes, we're using more. Our lifestyles are changing towards more rather than less, I think, yeah. But it's a way about what we are using, I think. Yeah.
Thank you, Katrina. Well, we have just a couple more. Jean and Ruth. I think some people have left the call, so we'll come on to the excellent new questions in the chat. Jean, did you want to add anything? No worries if not.
Yeah, no, it was just asking whether the impact of the natural cycle of the sun in terms of the temperatures it emits and its lifespan, how that impacts on climate change.
So there is a sunspot cycle, and I think it has a period of 11 years. That is kind of influencing the temperature on the Earth. So that's a real thing, and it's a natural one, and it's been occurring over centuries. And there are also other things like the position of the Earth towards the sun that are also like kind of astronomical things that impact our temperature. However, there is a very clear, so that is climate change, but not anthropogenic climate change. But there is a very clear correlation between greenhouse gases and increasing temperatures in recent years. And there's a so-called Mauna Loa curve, which has been measured in Hawaii of CO2. And it's kind of like a wobbly curve going up and up and up. And the wobbles actually come from the seasons. So, you know, if you have a lot of green around, it can take more of the CO2. And that's kind of how you get the wobbles. But it is going up. And if you put the temperature curve next to it, it's going up as well. And we are actually currently in a phase where, due to the astronomical situation, we should be heading towards the next ice age, but we're not. So I think that there's very clear, even though we have natural variability, there's very clear indication of anthropogenic one as well. Yeah.
Thank you.
You're welcome.
Brilliant. Could we go to Wendy next about car use? That would be wonderful. Where's Wendy?
Sorry, I wasn't sure if that registered or not. Yeah, I mean, obviously the trend in this country and Western countries is to go electric with car use. Yep. But I'm just thinking about the increased electricity we're going to be using and also the batteries. I don't know enough about the advantages of that over what we're currently doing. Just want to know your thoughts about that, please.
So I'm also not an expert on electric cars. I have to admit my work is on impacts of climate change. There are different ways to generate electricity, and obviously more sustainable ones than burning fossil fuels, versus in other cars you're definitely burning the fossil fuels. However, I actually question the choice of my parents recently, who decided to buy an electric car on top of another new car. So I think, you know, at that point, it also becomes a question of which resources are used to actually, you know, make this car, and do you really need a new car versus continue driving your old car, because obviously all the manufacturing and so on, it will also take a lot of, you know, things to make, to produce all of the greenhouse gas emissions that go into the atmosphere while you're making it. Overall, over long term, obviously, I think there is a point that electric cars are probably better for the environment because of, you know, the way that you could have green electricity fueling it and so on, or fueling, but like, you know, making it move. However, if it's next to a new shiny car that does use other things, and the resources that you needed to actually create this car versus having a used car and driving that a little bit longer, I think I would recommend really reading up on that, whether like at what point it becomes more sustainable to buy a new car versus keep driving the old one that, you know, has resources that we've already extracted and that has already been made and put the electricity into it. But yeah, I'm not an expert. I'm just saying that there are different perspectives on this, and definitely read up on it. Yeah.
Thank you.
Wendy was also wondering whether we should all become vegan.
Well, you don't need to go vegan, I think, but definitely reducing intake of meat and dairy is a big way to actually reduce your greenhouse gas emissions. So a lot of the methane that is produced actually comes from livestock farming. And while yeah, so I'm personally vegetarian, but I love my cheese. And I'm trying to reduce everything a bit. So I'm having, I'm having like vegan yogurts and oat milk and things like that. But, there's only so much that you are willing to do as well. And I think that's a personal moral choice that you need to make within yourselves. Kind of, how much am I willing to do if this is what is happening? And vegan cheese is nice. Depends. I found some good ones. Yeah, like as I said, like I'm struggling to go entirely vegan. But I think, if you're a meat eater and you really have meat every day, I think even starting to cut it out and have it, let's say, only at the weekend, that's starting to make an effort, I think. And I think it is in that way. The more you can do, the better. But if you're not going entirely vegan, I don't think, it's all personal choice, really. Yeah, that's all.
But looking at it from the other end, there are attempts here in Ireland, and I think there's a competition up to have carbon neutral farming, so that the farm does not produce methane very much. They have different feeds, different methods of treating the animals, of housing them. Some of them are outdoors all the time, eating entirely on grass. So there's that line of approach as well, which comes from the other end of the system, the procedure.
Yeah, I mean, I think a cow will always produce some methane, but there are definitely ways that you can have, different farming strategies to reduce that. I mean, yeah, like there are our personal life choices, and then the other one is also just more people on the planet, really, which is a big one. And like I have a phone here. I had another phone 2 years ago. The consumption that we are kind of, that every one of us makes our choices. So it's. But yeah, I think it is good to get yourself informed. I think that's the most important thing. Really know where your food comes from, for example. And then if you know that, make choices that you think you can, that you are happy with, basically. And sometimes it makes me happier to do the good thing if I love my real cheese, and sometimes I want my real cheese and forget about it for a moment. So yeah, I think that's kind of what I got to say to that. Yeah.
Great. Lovely that we've got Katie Drew with us from Melanesian Mission UK, Chief Exec. Welcome, Katie. You had a question about farming from your group, was that?
Yes, there was. It was the impact on farming on climate change and what kind of impact that has. And we talked about the sort of flooding that's going on in my village. And, the kind of the rumours that go around, it's because, it's the new housing estate that's been built on the floodplain, or it's that the farmer's removed his hedges, different crops. Is that likely to have had an effect on climate change?
Well, not so. Like, I think these all have an impact on the farming, but climate change is one driver having an impact on the farming. So, for example, this housing estate on the flooding plain, I think that is a big reason why there is probably more flooding now, because the water can't go anywhere where it naturally would go. So you might have more precipitation due to changes in weather patterns over time due to climate change. And then that is enhanced by other things that we're doing. So when we're thinking about the environment, our big word right now is climate change, but I think there are a lot more things than just climate change. There are our local human activities that we do, like, putting a new building in a place. And obviously then we have it's covered, so the water can't go into the soil at that point, so it must go somewhere else. And if there's more water, then that might lead to more flooding in that case. That's just one example. The air pollution that we are causing, that's not only affecting climate change, that is also affecting the air that we breathe in, and potentially, medical add-on effects on lung cancer, for example, which is a big one. It's really caring about our environment. Climate change is so big because it is global. It is everywhere, and we are affecting countries on the other side of the world with it from here. But then there's also these things that we're doing locally that are also affecting our environment. And we also, we're exporting waste. I'm from Germany, the UK as well. We are big waste exporters. So we send our waste on ships to, for example, the Philippines. And then there are these landfills, waste dumps everywhere. So every choice that we make basically has a net-on effect on the environment around us, or in the environment in a different part of the world, I think. But climate change is just one of them, and it's usually a driver of certain changes in the environment that are compounded with other things that are going on in the area anyways, and then lead to even stronger effects, I think, yeah.
So it's all linked. Thank you. Yeah.
Thank you, Marie. This is absolutely wonderful. I've missed some questions. Nancy had questions about resources, but we're running out of time, I'm afraid. I know that on your PowerPoint, you have got a whole slide of resources, haven't you, that will be circulated. So Nancy, you'll receive that. And then there's some suggestions for eco-church registration and all these very creative, more positive ways of looking forward, which we're coming to. So in the last minute, before we have our final short video, Marie, could you just give us an update on what's coming next week and the week after?
So next week, we will take a look at the Pacific in more detail, and we will look at what it actually means for people at the forefront of climate change. How have their lives already been changed, and how have they responded to it as well? So, all these videos that you've seen in part 1 and part 2, we will talk a lot more about those villages there, the people there, and what they've already been doing as well. And in the last one, in week 4, and I think that has been of great interest in our breakout group discussion, that will be a session where we are looking at practical climate action. So what can we as individuals and as groups, as churches, actually do to tackle climate change from a perspective coming from a Western country? I think that would be really interesting. We will have people from other organizations talking about the work that they're doing, how you can get involved with it. And I think that's probably the list of resources that you really want as an individual. Is it better to drive the electric car than the other car? I think that's what these people will be able to answer a lot better than I can. So for today, the resources will really be more on where can you find more information about what is actually happening and climate change. But if you're interested in what can I do, then definitely join the 4th session. Yeah.
Wonderful. And there has been a little delay in getting the video ready from last week's session because our administrator is on holiday, but it will be circulated to you all as soon as we have that, along with the slides from last week and the slides and video from this week. There's always a bit of a delay getting the video, but on behalf of everybody, we wish to thank you, Marie, for sharing your expertise, your passion, your commitment. I know you've dedicated a lot of your time to volunteer with Melanesia Mission UK as well, and you are giving of your time to teach us, as community dwellers. So thank you so much for bringing all that you have done for today. We've really valued it, and all the best with your PhD. We're just going to end in that first session last week. Liz gave a great talk about the theology of hope. We have to keep up this theology of hope, but we're going to just have some really joyful Melanesian music from the Sisters of the Church just to end. And bless you all. Thank you for being with us for this past hour and a half.
Thank you for joining and participating so much today as well.